we have var amount equals this dot heal. So hit F11. Now we're in the player class, right? So it can be a little confusing because you're going to the base class, and then this, when we say this dot heal, we're talking about an implementation that's defined in another abstract class that we're inheriting from that doesn't get implemented until player. So we override that and we define our own functionality. So when you're debugging this stuff and you're jumping down this rabbit hole, it can be a little confusing. But so we come in here, and then we calculate the boost from items. So we hit F11 on that. And we're just doing everything we decided to do before, which is run through the inventory, run through the things we're wearing, run through the weapon, and see if anything has a healing effect. And if it does, we'll add it on to our output. We have nothing. Okay. So then we've got our action strategy. So hit F11 on that. Now here's where we finally see that Gary is a carpenter. And as a carpenter, his healing strategy is to reduce his stamina by 2, meaning that for a carpenter, the active healing costs him 2 turns. And then he heals for 5. And so we come all the way back out to our string response, and we say Gary, Beth is the target, and his amount is 5. Then we apply that amount to Beth, who is the target. But again, inside of the game engine, because it's relying on the command pattern, doesn't care that it's Beth, doesn't do any checks to see who it is, just takes the target and calls its contractually obligated method that it has to have, and says, my only job is to expect you have this method and pass the value to it. I don't care what happens after that. It's none of my concern. And you can already see how a game engine might become more complicated, because right now we're applying that restore health in a vacuum. We aren't processing what happens next. So if you have a decently complex event tree, not just here, but in any application where you start thinking about this very simple event-based programming, you're saying, I want something to happen, I want to take the response and apply it to something else. Well, it's like this domino effect. Do you care what the response of that is? If it is, then you have to process that, pass on to the next, and decide when you terminate the ability for actions to have responses. Hang on, and I'm going to catch up in chat real fast. So Stropham asks, so the hive mind just takes generic actor objects as parameters and operates on them as a sort of third party. Sort of. In the third party terminology, we definitely want to start calling an abstraction. That's the phrase or the lexicon you're going to see out there in all the examples. So what we've actually decided is the hive mind takes in a game request, and it really has no. And so, as an abstraction, when we abstract out a part of the design pattern, we say the abstraction should only care about. Trying to find the words. I don't really know how to explain it. So the abstraction shouldn't care about the implementation. So if we passed in iActor, it'd be a little too coupled, right? Because then we wouldn't be able to process requests for inventory, and inventory aren't actors, and we might have other things in the game that aren't actors, and we don't want to push in that logic. So what we did instead was, inside of game request, we just said, hey, a game request is composed, and composed is another big term. So game request is composed of an action, a sender, and a target. The sender is of type iGameObject. So because everything in our world is of type iGameObject, it becomes our least common denominator. It's what we want to ensure that every object in the game has the iObject properties and can do the iObject things, right? So, and we had done that weeks ago. We had, from the very beginning, from the first factory, we said we want that to be our root, and then everything else will sprout from our iGameObject. What that set us up to do is when we then said the command pattern, we came all the way back down that tree, and we said, okay, every iGameObject should also be an iGame command. And so if we go into the interface for iGame command, the only thing iGame command expects you to have is an execute method that returns a request. And so by doing that here, we've immediately given, so not only does every game object have the ability to have a name, description, hit points, all that, but it also can now participate in the command pattern. So anything in the game has the ability to fight, heal, repair, and negotiate, which is a great baseline expectation to have. And even if we're running like a line of business application or a website, sometimes it's really good to have that, especially when we're doing abstractions, to say, okay, worst case scenario, I know this is a blank. And when you're in C#, or just .NET, it has its own base assumption, and that is that everything is an object. So everything you're passing around is an object, regardless of what you call it. And so we're kind of following that same methodology. And it's paying off, because when we come back into HiveMind, we can pass anything into HiveMind. We could say Gary wants to attack a seashell. And if the seashell is, we'll come back over to the game object, if the seashell is destructible, then we'll have it take damage, right? If it's not, it's really up to the seashell to make that determination, or whatever abstraction we have in front of the seashell. So as we start doing this higher and higher level programming, we're dealing with abstractions, talking to abstractions, relying on contracts. And I hope that's not too philosophical, but we really want to put our architecture in a space where it can be validated and it can operate independent of the implementations. And that becomes very important when we start looking at just how, if we go into player again, we've got classes, we've got particular inventory, we've got different items, fists, hammers, wearables, keepsakes, right? If we go into NPC, we've got our own structure that's independent of player, that can have its own complexity and its own trees and its own interactions. It's very refreshing to be able to code in any one of these domains almost in a vacuum, and then when we come back and want to extend the application, we can do so at the base game object without any concern for any of the things we did, and then at the same time kind of appreciate and understand it's still going to work. So Strophium says that the hive mind is essentially a hub where all actions take place, and it's partially a debugging feature. So you know when an action fails, it's always happening in that hub of the hive mind. That's exactly right. That is a great segue into how we can use it just as that, because we're processing all these game responses, and so it is a hub, and it does help quite a bit with our debugging, because we can very easily do something like this. We can say, okay, public stack of type game response, and we'll say response stack. Right? Oops. We're still debugging. Of course we are. Okay. So what this allows me to do is to go off of Strophium's point. We have this hub, and all the trains are coming into this station, right? And so as a result, we've got a great ability to either choke things off, expand on things, make decision logic in one place, or for the case of debugging and also just good auditing, we also have the ability to say, okay, when we create a new hive mind, also create a new response stack. And we aren't giving any capacity, but, and you have to look it up, the difference between stacks and queues, but essentially a queue is going to be a first in, first out, and a stack is going to be a first in, last out. So as commands come in, right, and they're adding to the bottom of this stack, we can maintain a record of all the things that happen in our game, which in any application you write could be critical, so that you don't have to go. We saw how confusing it can be to have to hit F10 and F11 and dig into base classes and abstractions and see what goes where. It can be painful if we can not necessarily shortcut that, but gain some insights at a higher level as another benefit of our architecture. So we can say, hey, right now in every action type we're returning the response. So let's change that. Let's say don't return the response yet. Instead, break. And so breaking will take you out of the switch statement. And so we're not returning out anymore. And so now we got a little red squiggly that says, hey, the return statement is missing. Well, it's by design, because we want to, now that we've got a response, we want to go to our response stack and push. I'm going to push that response onto the stack and then return the response. Right? So let's go back over to program. Make sure we made that public. And we'll go ahead and write and readline the message there. But then let's just copy that a few times. 1, 2, 3, 4. And then we'll readline. Okay. So if we put a little breakpoint there and we run it, let's remove that breakpoint and continue. Okay, so we executed a command, and if we now go and we